Hi there, this is an equations video on quadratic equations, having a look at a lot of key examples here. First example, we have a quadratic that we've factorized into brackets here, and it's equal to naught. So this involves one bracket with a multiply in between it, invisibly. So that means two items are multiplying with each other. Let's call them A and B as a general idea, equaling naught. Now, in order for two things to multiply together to give naught as the result, either A has to be naught or B has to be naught. We can't, if neither A nor B are 0, we can't get 0 as our product of those two things. So that's the idea we're using for solving quadratic equations here. If this is multiplying by this, either x plus 3 equals naught, and we'll write that down, either x plus 3 equals 0, or if that's not true, then x minus 4 must equal 0. That's the only way. One of those two ways has to be true for our 0 to be our final product when two things are multiplying together. So we'll just solve those two simple equations, minus 3 both sides. So x equals minus 3, or plus 4 both sides, x equals 4. So with our answers there, you can kind of see that there's a bit of a shortcut opportunity. If you've got a bracket with just x and a number in there, the final answers there end up being the minus version, or the opposite version of of plus 3. Opposite of plus 3 is minus 3, or the opposite of minus 4 being plus 4. So it's probably best to solve the two separate equations nice and carefully, even though that shortcut is possible, because it's pretty quickly you get to questions whereby the solving is the only sort of way to do it. It's pretty tricky if you're just trying to think of it in your head. So that's the basic idea of solving quadratic equations. Let's have a look at a few variations now. So here, once again, we have two things that are multiplying to give 0. So either 2x minus 3 equals 0, or x plus 7 equals 0. So we'll solve each of those equations. We'll plus 3 both sides. This is a two-step equation here, leaving us with 2x equals 3. We'll divide by 2, leaving us with x equals 3 over 2, we could just say there. Or if we minus 7 both sides, we'll be left with x equals minus 7 when that cancel each other out there. There's a bit of cancelling that happens here and here, and here and here, and here and here. That's why we're choosing those things to do to both sides. And we'll make sure we put an or there. So that's our final answer there. We don't need to put a box around them, but sometimes it's good to highlight to the marker what your final version is. So our results there are two different results, depending on whether the first bracket equals naught or the second bracket equals naught, because it must be one of them. Otherwise, we wouldn't get naught as our final product on the right-hand side. Alright, now this hasn't been factorized for us, so we'll have to factorize first here. What's common between here? I think x occurs in both of this term and this term, so we'll put x outside of, and then we'll say to ourselves, what have we got to multiply x by to get x squared? We'd need another x in there. Then we'll ask, what have we got to multiply x by to get 2x? We'll need a plus 2 in there, and we'll have that equaling 0. So first of all, we'll factorize, and then it's a bit like previously. If this has an x in it on its own here, we have to take into account that that's one term and that front number is one term as well. When there's a letter there, we have to treat it like a separate term. So here, if these two things are multiplying with each other and giving 0 as a result, we said that either x equals 0 or x plus 2 equals 0. Now this is already a result, so we'll just write that down as a result for that right hand side. We didn't have to do anything to get x on its own there. Here we have to minus 2 both sides. X equals minus 2. So the only bit that we had to do there, other than the previous examples, is we had to do the factorizing, and then we followed that normal quadratic result thing where we have one thing equal to naught or the other thing equal to naught. And they're making us do some more factorizing here. These ones look hard to factorize unless you spot the shortcut or the rule we're using. We'll write this as, instead of m squared minus 16, we'll write as m squared minus 4 squared, because there's a special arrangement of factorizing we can do when we have one thing squared minus another thing squared. I'm sure you'll remember this. M minus 4 can be in one bracket and multiplied by m plus 4 in the other bracket. That's the difference of two squares. Shortcut rule, I like to say there. Now we've got something very similar to our first example. Either m minus 4 must equal 0 or m plus 4 equals 0. Let's just solve that little equation. M equals 4 or minus 4 both sides. M equals minus 4. I suppose there you could write it like this as well. You've got this and you can write it out separately, no big deal. A shorter way of writing it would be m equals plus or minus 4. Maybe. Okay. Next one. This one looks a bit trickier, but we've got to put this into one thing squared minus another thing squared is our only option, because there's no numbers or letters that go into both of those. So let's write 9k squared as 3k all squared minus 2 squared. Then we fit it into one of those difference of two squareds arrangements. That allows us to say the brackets for the factorizing is 3k minus 2 in one bracket and 3k plus 2 in the other bracket. Doesn't matter which order you've got those brackets, because they're multiplying, and order doesn't matter when you're multiplying. That allows us to say either this bracket equals 0 or this bracket equals to 0. 3k minus 2 equals 0, or 3k plus 2 equals 0. Two-step equations to solve here, making us work fairly solidly, leaving us with 3k equals 2. We'll divide by 3, divide by 3. K equals 2/3, we could say there. Or, let's minus 2 both sides. 3k equals minus 2. Divide by 3, divide by 3. K equals minus 2/3. Okay, should have written that a little bit lower there, but there's our answers there, either 2/3 or minus 2/3 there. So we had to spot that we could factorize it using the difference of two squares, and then we're saying, okay, either the first bracket equals 0 or the second bracket equals 0, and solving each of them. This one is a quadratic that we have to factorize. So if we had to factorize that, we'd probably be thinking PSF or a cross method. It's up to you how you've been taught there. I'm going to do it this way because I like this way. The product of the two numbers we're going to put in brackets. We're going to have x and another x, and that's all going to equal 0. The two numbers we put into the brackets here, the two numbers have a product of 12, which we get from here. And they have a sum of 7, which we get from here. And we have the F stands for factors, the factors of 12. 1 and 12 isn't going to work very well. 3 and 4 is going to work beautifully, because 3 plus 4 is 7. So we'll have plus 3 and plus 4 there. Then we can say the usual thing for solving quadratics, either x plus 3 equals 0, either the first bracket equals 0, or x plus 4 equals 0, and we'll solve that pretty smartly. X equals minus 3, or minus 4 both sides. X equals minus 4 as our final answer. So we had to do our PSF, factorizing of the quadratic on the left-hand side. Then when we got our brackets, we did the usual process of solving quadratic equations. This one's going to make us work hard again. We have a PSF factorizing opportunity here. You might remember from a previous video, the way we respond to an extra number on the front there is that our product of the two numbers that are going to go in the brackets is going to be 2 times 2 here, and the sum is going to be the 5 there. Factors of 4, 1 and 4 is going to work quite nicely. But what we do here, and another adjustment for the fact that there's a 2 out the front there, is that we split that middle term up. Instead of saying 5x, I'm going to express 5x as 4x plus 1x, and split it that way, and then I'm going to factorize in pairs. Have a look at the previous factorizing videos, because we do quite a few examples there. Okay, what's common between the first two here? I think 2 and x can come out of this first pair, and we'd have to multiply 2x by x and 2 to create 2x squared plus 4x. Now here, the only thing that's common between here is 1. Doesn't usually help us much, but we'll put a plus 1 in front of x plus 2, and I am encouraged by the fact that this bracket and this bracket are equal to each other. You'll recall, if you've seen these before recently, that you're allowed to join the front numbers, the 2x and the 1, into their own brackets, and just list the x plus 2 once after it. So they're allowed to join up in that situation, only when the brackets are the same as each other though. Alright, so we've finally got down to our quadratic factorized version. So we say that 2x plus 1 equals 0, or x plus 2 equals 0. So one of those brackets has to equal 0 in that situation. Let's solve the little equations. 2x equals minus 1. We'll divide by 2. Running out of room. Just got there, I think. Minus a half. Or we'll just minus 2 both sides. X equals minus 2. So that's our answers there. Just had to do that slightly trickier version of factorizing this quadratic. We had to adjust in 2 different ways there. Factorizing in pairs is the way I like to do it. There's lots of different ways to do that. So there we have it. We factorized. Then once we got the brackets version, we said either one bracket equaled 0 or the other bracket equaled 0, and then we solved those 2 scenarios. Alright, this one is going to be solved by completing the square. It's an interesting little process here, so let's get stuck into it. X squared plus 8x, and I'm going to be careful how I set this out. Okay, I'm going to add 3 both sides to my original here, just so I get that 3 on the right hand side. So I'm going to say, I'm going to keep my x squared and my 8x there, and I'm going to say, well, I'm going to move that across to that side there and get rid of it on the left hand side, because I'm going to complete the square on the left hand side here, and the opposite of a opposite of a minus 3 is a plus 3, so I'm going to make that 3 over there. It's a bit strange, but I'm making room for completing the square inside here. So let's get a different colored pen. Now a number that completes this square is we divide 8 by 2 and get 4, and then we square 4 to get the number that I'm going to insert in here. 4 squared is 16. So how did I get 16? I halved 8 to get 4, and then I squared that result. That's how you complete the square there. And because I've added 16 on the left hand side, I'm going to make sure I add 16 on the right hand side. Otherwise we'll be in big trouble. Okay, now once we've done that, completing the square, we haven't really written it as a square though. The square version of that is x plus 4. Now I got that 4 from the halved version of 8, or I could get it from the square root of the 16. Anyway, I'm here to tell you that x squared plus 8x plus 16 ends up being x plus 4 all squared, and that equals 19 there. So that's how we complete this square. Quite involved. The reason why we added 16 both sides, we can't just randomly add 16 to the left hand side of an equation and not the right hand side, so that's how that worked, and that was able to join up there. Now if we take this as a separate sort of question, if we square root both sides here, we get x plus 4 equals plus or minus square root of 19. Now I'll just remind you, if we say x squared equals, I don't know, 25 for example, this is just showing you how it works. If we square root both sides, we could have x equals 5, or x could be minus 5 as well, because we could square minus 5 and still get 25. So that's where our plus or minus comes from out the front of there. And so all we do to get x on its own now is to the opposite of plus 4, which is a minus 4. So what we end up with is x equals plus or minus square root of 19 minus 4. So that's our final result for x by completing the square. Pretty weird, but they're the same each time pretty much, those ones. So that's interesting. We completed the square there and it worked out to be this as our final version. Don't forget that plus or minus when we have to square root both sides. We'll see another example where there's a minus in there. Okay, we'll do a similar thing as what we did just then. We'll just write out y squared minus 6y, and I'm going to put this plus 4, I'm going to make it a minus 4 on this right hand side. Okay, to complete the square here, I'm going to divide this by 2, so I would get minus 3. Then I'm going to square that and make 9 there. Minus 3 times minus 3 makes positive 9. I'd better do the same to this right hand side. Now the square version, the completed square version here is y minus 3, which is like the half version, squared there. And that will equal 5, because minus 4 plus 9 is 5. Okay, so then when we square root both sides, we'll have to not forget our plus or minus version here. We'll that square root and that square will cancel each other out. Equals plus or minus root 5. And just to get y on its own here, we will plus 3 on both sides. So y will equal in the end plus or minus root 5 plus 3. Quite a bit to think about in the one question there. Okie dokie, let's have a look at the next one. Quadratic formula. Okay, now this is when the numbers don't work out very well to do PSF or cross method or whatever your teacher has given you for the easier type, more straightforward quadratics. This one is, or sometimes, the question asks us to leave the solution to this in surd form. That's another clue that we're going to be using the quadratic formula. Or it might say solve to 2 decimal places. That's another clue that we're using the quadratic formula. And the quadratic formula, I'll just write out here, x equals minus b plus or minus square root of b squared minus 4ac all over 2a. Now that's based on a, b and c being the 3 numbers that are in front of the 3 terms here. In this case we don't have a number, or we didn't see a number that's in front of the x squared, so there must be a 1 in front of there, otherwise it wouldn't exist. B will be the number that's in front of the x, and c will be our 5. That's where we get our values for the quadratic equation work here. So x equals, let's have a look at it, let's piece this together using these numbers here. Minus b, in this case minus 7, plus or minus square root, b squared is going to be 7 squared, minus 4 lots of a, which is 1, lots of c, which is 5, all over 2 lots of a, in this case 2 lots of 1. X will equal here minus 7 plus or minus, 7 squared is 49, minus 4 times 1 times 5 is 20, so we'll go with square root of 29 there, all over 2. Now when you've got a plus or minus here, you could write it out as a plus version and a minus version. So you could, in many textbooks, have the plus version of minus 7 plus root 29 all over 2, or minus 7 minus root 29 all over 2. So sometimes they ask you, well, sometimes people expect you to write that out separately. So using this quadratic formula, that finds a solution to quadratic equations. Take your A, B and C from the values in your original question and plot those things and substitute those values in really carefully. Okay, quadratic formula again. I'll write it out again because I'll forget otherwise. Minus b plus or minus square root of b squared minus 4 lots of a lots of c all over 2a. This time a is going to be 3, b is going to be minus 4, and c is going to be 7. Now let's piece this together, and something a bit interesting happens here. Minus b, now b is already minus 4, so we're going to get a positive 4 there. Why don't I put in minus 4 just to show you? Plus or minus the square root b squared, so you got minus 4 squared, careful with the substitution there, minus 4 lots of a, which is 3, times 7, which is c, all over 2a, which is 2 times 3 in this case. So x equals, we get 4 when we minus a minus, plus or minus. Now, minus 4 times minus 4 is 16. Minus, now 4 times 3 is 12, times 7 is 84. Over 6. Now the problem is here, you will get, if you continued that, we'll just simplify this bit in here, and we actually get x that's supposed to equal 4 plus or minus square root of minus 68, is it? Let's have a look. Yeah, minus 68. Now I'm here to tell you that square root of a negative number doesn't work very well in the calculator. So instead of saying solve, I made up this question, so it's probably my fault, but instead of saying solve this by quadratic formula, this question probably should have said something along the lines of show that there are no solutions for this using the quadratic formula. And the reason there's not going to be any solutions is that you can't have the square root of negative here. So we would say here that there are no solutions because you cannot solve square root of a negative value in this case. So that one didn't work all that well, but at least we know how. I mean, we would have got correct answers if the values were correct, but I've made up this question and the values were such that we couldn't get solutions there. Now every now and again, I'm not going to apologize too much here, because every now and again the questions are designed not to have solutions, and it's good for us to know when that can occur. Okay, so there's quite a lot of techniques used to solve quadratic equations. We either use the formula like we have in the last couple of examples. Sometimes they give us a factorized version that we make one of the brackets equal to 0 or the other bracket equal to 0, and we solve each of them. And sometimes they ask us to do the factorizing and then solve the equation from there. I hope that range of examples has helped you a lot there, and we'll catch you next time for some more great videos on peterblakemaths.com. Quite involved, those ones, but a similar sort of process each time, so they shouldn't be too bad if you get the hang of them and get lots of practice. All the best with that. See you next time. Bye bye.